Hello to everyone, my name is Alessio Palmero Aprosio from Fondazione Bruno Kessler in Trento, and I'm going to present you a joint work with Stefano Menini and Sara Tonelli, which title is Adaptive Complex Word Identification through False Friend Detection. Let's build inclusive societies. One of the main steps to reach this goal is to allow citizens to interact with the society in which they live, in particular with the public administration. In this paradigm, citizens need to understand documents even if they are not native speakers. Often, citizens with lower proficiency, for example migrants, are those that most need access to services. We focus on the task of complex word identification, that is, given a text, predict which words challenge a target given population. Therefore, to let people have a better experience in interacting with the public administrations, one way is to build systems that amend the text, which need to be understood, by editing them or making them clearer. The goal of our work is to develop a system that accepts as input a text in Italian and the user mother language. There are also many shared tasks on the topic of complex word identification. A shared task is a competition where teams of researchers are invited to solve a problem, and then a ranking is done and a winner is nominated. Standard approaches to complex word identification only consider frequencies of lemma in the language as an evaluation of complexity, but native and non-native speakers consider different words as complex. We describe a novel, user-oriented and adapted approach that considers from similarity between words in different languages. Our target are, in particular, non-native speakers. We will describe an approach based on false friend and cognates. False friends are words in two different languages that are similar in form but semantically divergent. For example, library in English and libreria in Italian. Cognates, on the opposite, are words with the same meaning and a similar spelling in two or more languages. For example, color in English and couleur in French. In this paradigm, a user speaking English as a first language will consider the Italian word libreria as more difficult than rare words that have a similar sound in English. This is why, in our study, we consider false friends as complex words. This picture shows the architecture of our systems. Some part of the pipeline needs some preprocessing steps that should be infeasible on the fly, and these are the part with the blue background. Using the models generated by the offline phase, the pipeline can parse documents in real time. The white background graphs show the processing that is done each time a new document needs to be parsed. First of all, a text in language L1, in our case Italian, and the user language L2 are given as input. Then the text is pre-processed to get lemmas and content words using a natural language processing pipeline. The system then outputs the complex words found in the document. The yellow part of the pipeline is divided into preprocessing and online phase. In the preprocessing phase, for each pair of lemma in L1 and L2, the two languages, we compute similarity measures using XX-Dice, NED, and Jara-Winkler. To do so, we use multilingual lists of lemmas, and then the similarity values are calculated all tokens against all tokens, resulting in millions of values for each pair of languages. This is why this computation is done offline. Each of the three measures had advantages and disadvantages. For example, Jara-Winkler matrix boosts the similarity of words with the same root. As a result, two words that are close according to a matrix can be very different using another matrix. To overcome this limitation, we balanced the three matrices by computing a coefficient for each of the three scores, tuning them on our manually annotated set. Then, for each content word, we identify a list of lemmas that are similar in the two languages. In the green part, we will train a support vector machine model. The first phase is to align the English, French, German and Spanish monolingual embeddings to the Italian ones, using fast text vectors and multilingual dictionaries. Then, synonyms lists from a dictionary are given. Then, the cosine similarity between the word in Italian and a word in the language is calculated as a measure of the semantic similarity between the two words. In addition to the cosine between the two words, we also calculate the cosine between the synonym of the Italian word and, respectively, the original Italian word and the word in the user mother language. We then consider both the nearest, where the cosine is maximized, and the average value of the cosines of all the synonyms. Then, an SVM classifier is trained and is tuned using a 10-fold cross-validation for every language pair, and the best model for every language is used in the production pipeline. More details about the implementation can be found in the paper. Four datasets were manually created by a linguist with experience in teaching a language for second learner. The datasets are then manually checked by another domain expert, and each dataset contains pairs of orthographically similar words marked as either cognates or first friends. The languages considered are English, French, German, and Spanish, with Italian as the main language. And all data is available on GitHub. This table shows the content of the dataset for each language and the number of cognates and false friend tokens in the dataset with the total, the sum of the two values. Obviously, the list of cognates is not meant to be exhaustive. This table shows the different accuracy in the different configuration of our SVM classifier. In feature selection, Romance languages boost the accuracy of the classifier. As said, we use a 10-fold cross-validation to tune our parameters and extract these results. As you can see, if you use all the features, the accuracy boosts. In these slides, you can see the results on a test set in the various languages with precision, recall, and F1, and obviously accuracy. We can see that our system works better on Spanish and English. This is due to the similarity between Italian and Spanish, and because the English dataset is bigger than the other ones, probably covering almost all the more common false friends. We randomly collect 500,000 sentences from a multi-domain Italian corpus. We remove all sentences containing at least one word for our training sets, resulting in a set of 24,000 sentences. LBI is the lexicon of basic Italian, written by De Mauro. It contains the 7,500 easiest Italian words, split into three categories: fundamental Italian vocabulary, most frequent used, and highly familiar. The LBI small row represents only the first set. Generally, the vocabulary-based approaches are less conservative and award less frequent words. A strategy targeting the language of Italian non-native speakers, instead, seems to be more focused. This slide shows some example sentences with different complex word identification strategies. LBI small output is in bold, while the results of our system is shown into brackets. In these examples, responsabile, colpevole, omicidio, and attualmente pausa and tournée are considered difficult by the LBI small dataset, while rende and attualmente are false friend in English and are considered complex by our system. For example, rende is similar to the verb to rend, that is rompere in English, and attualmente is similar to actually, that is a false friend in English. Also, prendendo is a false friend in Spanish, as it means accendere. An online demo is available at this address and is part of the framework for text simplification developed in the Simpatico EU project. We can see it. Here you can enter some text, for example, oggi vado in libreria con alcuni amici. You can click on process text, and then you can see a lot of linguistics annotation, but here there is lexical simplifications, and you can see that libreria is shown as a complex word, for example, in English. If you click on English, if you click on French, the word libreria disappeared because it's not considered as a complex word in French, as it's not a false friend. In conclusion, we present an integrated pipeline to identify complex words for language learners adapting to the native language of the users. We describe a supervised approach to automatically detect false friend in 4 language pairs. We show that standard frequency-based approaches do not address the needs of users with different native languages. In the future, a more complex setting using the context will increase precision. We want to add more languages to our system. We also want to consider multi-word expression, as for now the system only considers single token expressions. And we want to involve users in the evaluation of the pipeline, for example, allowing them to submit a feedback to compare the standard and the personalized complex word identification. Thank you for your attention.